We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Good morning, friends. Today we will see about the gravimetric analysis, and it is the main chapter in the first semester of pharmaceutical analysis subject. In the gravimetric analysis, we will discuss about the principle, theory, various types of application as well as advantages of gravimetric analysis. So, starting with the principle of gravimetric analysis, it is a type of analysis in which the isolation, weighing, and drying of the precipitate take place. For example, in progesterone injection, the content of progesterone is quantitatively determined by this method. In the principle, we can see the 4 bullet points in which the precipitation method is widely used and applicable for the various compound to analyze by gravimetric analysis. Second one is the volatilization method. In this method, the sample is completely volatilized and transferred and dried accordingly. Third one is the electrochemical and electroanalytical methods in which the sample is deposited on an electrode, and by doing so, we can analyze the analyte in the given solution. Fourth one is the extraction and chromatographic methods in which the separation of the components in the given matrix or mixtures will take place. The following steps are very essential for gravimetric analysis. First one is precipitation of sample solution, separation of desired constituent as precipitate, weighing of isolated constituent, calculating the amount of particular constituent or analyte in the given sample from the observed rate. Theory includes various types of techniques and a principle which is very essential to understand the particular gravimetric analysis. For example, in the given um, reaction between NaCl and AgNO3, we will get the precipitate of AgCl and the byproduct NaNO3. So that NaNO3 has to be removed in the washing part of the gravimetric analysis. The first one, that is law of mass action and reversible reaction. To understand this, we have the example of reaction between the BaCl and H2SO4 concentrated sulfuric acid that gives the precipitate of a barium sulfate and 2 molecules of hydrochloric acid. And it is a it is the reaction, it is the forward reaction, and the rate associated with that is equal to the concentration of BaCl2 into concentration of H2SO4 into K, where K is the ionization constant. Second thing is a reversible reaction, and to understand and to comprehend it, we have the example of the same example that we discussed before, the reaction between the barium chloride and hydrochloric acid to produce the precipitate of barium sulfate and 2 molecules of hydrochloric acid. That is important because the reversible reaction, it produces the equilibrium between the product and the reactant. And to understand that, we have to understand the equilibrium constant which is given over here. That is the uh, that is the constant which governs the equilibrium between the reactant and the product. The condition for completion of reaction and thus undergoing reversible reactions are formation of particular soluble solid, formation of slightly ionized molecule, and formation of an insoluble gas. The third thing is the principle of solubility product. And why it is important? Because the solubility product governs the dissociation between the ions. For example, here the precipitate barium sulfate, which is formed between the reaction of barium chloride and sulfuric acid. It produces the ions, which is barium and sulfate, and the solubility affects in the solution governed by the solubility product, the principle of solubility product. So, and to understand this, we have to understand the product which is formed in the given analysis. The final and the foremost is the common ion effect, which is due to the same thing that is precipitated out in the given reaction, which is barium sulfate, and at the equilibrium, the barium ions concentration is equal to that of the sulfate ion concentration, and the supernatant liquid contains a saturated solution of barium sulfate. And this is the thing which the students and the mentors you have understand that the equilibrium and whatever the ionization constant associated with that, that has to be justified accordingly. The precipitates form during the analysis may be crystalline, curdy, and gelatinous, and crystalline precipitate are in well shape is a function of composition of salt, while curdy precipitate are aggregates of small porous particles, and gelatinous precipitates are gel-like and very difficult to separate out. So, what is the ideal condition of precipitates? And that is the important questions which is frequently asked in the GTU examination. So, what are the ideal properties? The first one is the precipitate form should be insoluble. That is the most prime requirement. Whatever the precipitate that is formed in the reaction or whatever the analysis is there, it should be insoluble. The second thing is physical nature of the precipitate should be such that it can be easily removed by filtration. Fourth thing is precipitate should be stable to atmospheric temperature. And the fourth thing is the precipitate should be convertible to the pure compound. These are the four and prime requirements for the ideal gravimetric analysis. Mechanism of precipitate, as you can see over the pictorial diagram or the pictorial representation, that the there is a spontaneous and induced mechanism which is associated with the precipitating agent, and the second one is the precipitate itself. So the purity and filtrability of the precipitate depends upon the particle size of the precipitate, and the particle size is determined by two processes, namely nucleation and particle growth. Nucleation is the productive of extremely small particle capable of spontaneous growth, and the particle growth is the growth of nuclei. Here you can see the nuclei is a very small cluster of the molecules as well as the solvent molecules which is entrapped in that, and this nucleation process can be spontaneous, where it occurs onto its own or induced using a seed particle to get the nucleation. We can induce also by precipitating agent. We can add the precipitate so that we can add the precipitating agent so that it can be induced, and ultimately we can get the precipitate. Co-precipitation. So this particular co-precipitation is a type of impurity mechanism which is involved in the gravimetric analysis. So we have to remove the problem like co-precipitation and post-precipitation that we will discuss later. But here the co-precipitation is a problem because the undesired impurities often co-precipitate with the analyte, resulting in excess mass of final product. This problem can be overcome by the digestion process, and these are the four mechanisms of the co-precipitation. First one is self-adsorption, second one is a mixed crystal formation, third one is occlusion, and fourth one is mechanical entrapment. So what is the surface adsorption? Is the adsorption is a surface phenomena, as we all know about that. So is a common source of co-precipitation. It causes a significant contamination of precipitate. Adsorption does not occur in crystalline solids. The adsorption process can be overcome by desorption. So desorption is the process in which the adsorbed ion from the surface of the precipitate enter into the solution. So after the adsorption, there is a desorption, which ultimately uh, produces the impure solution and which has to be removed out. Here is the mechanism of the surface adsorption, how the main precipitate is in the middle and how the other ions get attached to the precipitate surface of that and produces the impure solution. Second one is a mixed crystalline formation. It is the troublesome phenomena in which one of the ions in the crystal lattice of the solid is replaced by an ion of another element. The black dot in the crystal, as you can see, is the impure one. That is the another ions besides the precipitate ions and form the impure precipitate. Third one is the occlusion. In the diagram, you can see the counter ion is fixed in the position of the molecules of the precipitate. Instead of that pure precipitate, we are getting the impure precipitate because of these counter ions. Fourth one is the mechanical entrapment. As you can see, the gap inside the precipitate, because of that, there is a void volume, and that void volume contains the some amount of the solution, which is already there in the precipitating solution. So mechanical entrapment is low when the rate of precipitate formation is low. So according to that, we have to optimize the size of the precipitate so that we cannot get the mechanical entrapment of the solution, and after all we are getting the pure precipitate. Post precipitation, similar to the co-precipitation, the post precipitation produces the impure or contaminated precipitate, and to remove it out, we have to use the electrolyte solution. Proper electrolyte solution like ammonium chloride can easily remove the impurities which is adhered to the post precipitation and co-precipitation. Sometimes when the precipitate is allowed to stand in the presence of mother liquor, the second substance will form the precipitate with the precipitating agent. The process by which an impurity is deposited after the precipitation of desired substance is termed as post precipitation. The GTU most IMP question, differentiate between the co-precipitation and post-precipitation. So how you can differentiate it? By the adequate proper uses of language and by sentence construction, so that you can understand there is no need for complex sentence formations. The simple sentence can easily involved in your sample answer so that the examiner can understand how you are writing and what kind of views that you are producing in your answer. So longer the precipitate remain in the mother liquid solution, greater chance of precipitation. Example is that magnesium ion is present and as an impurity along with the calcium. Then they are doing calcium oxalate. There are chances of post precipitation of magnesium oxalate. This can be avoided by maintaining a high pH. So here the solution can be the adjustment of the pH towards the higher side, so that the impurity such as magnesium can be removed in the calcium oxalate precipitate. Steps involving gravimetric analysis, another most IMP questions which is frequently asked in the GTU examination. And these are the following steps. 6 steps involved in the gravimetric procedure. First one is the precipitation of the solution. Second one is the precipitation itself, digestion of the precipitate, filtration, washing, drying and ignition, and weighing and calculations. Gravimetric analysis is the pure analysis in which there is no any kind of sophisticated instrument required or any analyst which is highly qualified. Even the labor person can do the gravimetric analysis effectively. So first one is the preparation of solution. Sample solution has to be first prepared for the analysis. The precipitation is carried out using dilute solutions. So the requirement for the dilution is necessary and compulsory to get the desired amount of precipitation. Adjustment of volume and pH is important to get the desired properties of precipitant. Second one is precipitation itself. This step requires the addition of precipitation agent in the form of solution to the sample solution. After the addition of first drop of the precipitating agent, supersaturation occurs and nucleation starts to occur, where the molecules of precipitate aggregate together and forms the nucleus. So this is the foremost requirement to form the nucleus, and on the basis of the nucleus, other molecules of the analyte will come together and form the crystal. At this point, addition of extra precipitating agent will either form new nuclei or will build on existing nuclei to give the precipitant. Third thing is the digestion of the precipitant. The important advantage of the digestion is the conversion of the colloidal particles to the coagulated particles. We get precipitate with good crystalline properties. So that is the basis of digestion, and how we can perform this procedure or the step is by doing the one of the step, that is the solution has to be left hot for 30 minutes to 1 hour, and it is the ideal condition where primary precipitate form may be crystals of imperfect structure. Such particles has to be subjected to digestion. Digestion involves the dissolution of small particles and reprecipitation of larger ones, resulting in particle growth and better precipitate characteristic. This process is called the Oswald ripening. Here the student must have to remember that what is Oswald ripening, and that includes the formation of nuclei, and on the surface of it the other molecules come and attach to that, so that the bigger size of crystals we are obtaining. That is the basis of the Oswald ripening. The most important advantage of digestion, as we already discussed, is the conversion of colloidal particles to the coagulated one. Fourth one is the filtering and washing. In this operation, the precipitate is separated on the from the mother liquor. Various types of filter media is used for this purpose, like filter paper, gauge crucible, filter pump, and etc. It is the ideal requirement that whatever type of the equipments or the instrument used in the gravimetric analysis should be clean enough, and they have to be at the ideal condition, 1 atmospheric temperature and 25 degrees centigrade, so that the deviation should be not there from the given SOP or standard operating procedure or given written procedure. After filtering the precipitate, the impurities on the surface of the precipitate can be removed by washing. Large amount of water must not be used for washing because some of the precipitate may be lost. In the case of colloidal particles, we can use dilute solution of nitric acid, ammonium nitrate, and dilute acetic acid. So generally, these are the reagents or the electrolytes which can be used effectively while washing the precipitates, because ammonium nitrates and the dilute acetic acid are volatile in nature, and after the volatilization they will removed from the main precipitate and lefting behind the pure precipitate, which is very essential to the given analysis. Drying and ignition. The main objective of drying to remove and the water tapped in between the precipitate particles. The drying and ignition process will depend upon the weight of the precipitate. Drying can be using an oven at temperature of 120 to 150 degrees centigrade, and this is the condition for drying. What is the condition for ignition? That the muffle furnace temperature should be in between the 600 to 200 degrees centigrade. In that temperature, all the organic impurities in the form of carbon dioxide will be removed away, and in the drying operation, the water molecules inside the precipitate will be removed away. So a constant weight can be obtained. This can be achieved only when the process of heating, cooling, and weighing is repeated. So there should be a repetition of the process, so that we can get the adequate amount of precipitate as well as in the pure form, because any molecule of the water or any organic if remained in the precipitate, that will act as an impurity in the given analysis. Weighing and calculation. The foremost and the most important part is the weighing and calculation, and in that, whatever the crucibles or whatever the weighing apparatus we are using, it has to be clean and conditions before the weighing of the any of the initial weight of that crucible. In the usual gravimetric analysis, the precipitate is weighed, and from this value, the weight of the analyte in the sample is calculated with the help of gravimetric factor. So, what is the gravimetric factor? That is formula weight substance salt divided by the formula weight of the substance weight. So, in the given analysis, if the estimation of barium sulfate take place, this is the reaction, and the final product is the barium sulfate. So, in the gravimetric factor, the barium chloride weight will go into the numerator, and the substance weight in which we are getting the final product, that is the barium sulfate, will go into the denominator of the gravimetric factor calculation. The weight of the specific analyte in the weight precipitate can be found using the formula percentage analyte is equal to weight precipitate into gravimetric factor into 100 divided by weight of the sample. This is the ideal and most important calculation for the gravimetric analysis. The another important question is the estimation of barium sulfate, which is also frequently asked in the GTU examination. That is, write a note on estimation of barium sulfate. So in that condition, we have to describe about the principle and experimental methodology involved in that. So what is the principle involved in that? When the dilute sulfuric acid is added to the dilute solution of barium chloride, a white precipitate of barium sulfate is formed. This is the reaction. The reaction between the barium chloride and hydrogen H2SO4 produces the barium sulfate and two molecules of hydrochloric acid. This is the experimental methodology where we have to pipette out 25 ml of the given solution of barium chloride in 500 ml of beaker, and then we have to add the 0.5 ml of the concentrated sulfuric acid in 100 ml of distilled water, and then the heating and boiling required so that the hot solution will we are getting in that we have to add the sulfuric acid drop wise with constant stirring until the precipitation is not complete. After all the thing is happened, we will get the supernatant liquid and the precipitate at the bottom of the beaker, and after that we have to perform the operation of filtration, and after that we can weigh the compound, and before the weighing, the washing is very essential, and that is performed 3 to 4 times the repetition so that we will get the pure precipitate. And of course it will require comparatively more time compared to the other operations, and it has to be done with the hot water. Now whatever the remainings are there, it has to be checked out with the use of appropriate precipitating agent so that we can get the idea that whatever the remaining or the filtrate that is free from analyte of interest that we are analyzing. This is the calculation of barium sulfate precipitation. In that, how we can get that the first the theoretically and then final use of the gravimetric factor that is involved. What is the advantages of gravimetric analysis? The analysis is very accurate. As we can see, there is no any kind of complicated operation required. Instrumental errors is very less, as only one equipment, I think the weighing balance is used, and in the weighing balance that is a very simple equipment to use. Anyone any with proper training can handle this kind of equipment, and the weighing operation, and after the weighing operation whatever the drying operations or other operations are there, that is also very simple and less tedious, do not require calibration. Besides the balance itself, there is no any other complicated equipment used in the gravimetric analysis, and there is no need of calibration as only accept the weighing balance itself. It is simple and cheap, and then do not require expensive equipment. Very precise method when compared to other analytical techniques. Filtrate can be examined for completion of reaction, and this is the most important thing to where the error can be minimized to check the filtrate that whether it is free from the given analyte of interest or not. Application of gravimetric analysis. Extensive number of inorganic ions can be easily determined. It is most widely applicable analytical procedure. A variety of organic substances can be easily determined, like lactose in milk products, cholesterol, and in cereal, etc. Generally, the organic substances which are analyzed by the gravimetric analysis is generally rich in proteins and carbohydrates, and they can be generally incinerated out in the form of carbon dioxide. As we will see, we have already seen that during the drying operation there is an incineration procedure which will take place around about 600 to 1200 degrees centigrade, and at the temperature all the organic material will be removed out in the form of carbon dioxide. So that is the thing. The leftover or the remnants will always be in the form of salt, and that can be effectively weighed out. Generally, one test is the sulfated ash determination, in which all the organic impurities will be removed out at the 600 to 1200 degrees centigrade, and the leftover the remnants will always be the salt, because the salt has a higher melting point compared to that other organic impurities. To determine the atomic mass of many elements, as heavy metals and other like cerium and lead and copper and all these elements which are present in the given analysis can be effectively determined by the gravimetric analysis. Elemental analysis of organic compound can be done. The composition of elements of the compound can be done. The analysis of rocks, ores, soils, etc., and other inorganic samples for their major components can be carried out. So this is the applications, the foremost applications of the gravimetric analysis, and which is also generally asked in the GTU examinations. The students are most afraid of the this type of questions, but I think by doing the effective reading and writing, the student or mentor can easily analyze those type of questions and can easily write in the GTU examination. Thank you. This is the end of the lecture.